Let's talk about data collection and working with data. In this lesson, we're going to specifically look at data collection and graphing. And so basically the idea of what are the key terms, what do we need to know about how data is collected, and then how do we represent it? Because sometimes we collect data and we get a big chart, and that's great, but it's hard to look at a big list of numbers and get a feel for what's going on. So humans are visual creatures, so it's helpful for us to have a graph, a special kind of picture we can look at where we can observe trends and say, oh yes, I can see the price of gas is going up, or the price of gas is going down, or oh, I can quickly see what is the favorite flavor of candy among the class, or during which month was most people born. So graphs are useful in order to help us quickly get a feel visually for what's going on. And then we'll also talk about measures of central tendency, which is basically the idea of choosing a single number to represent a set of numbers. So think about our class. If we have 20 different people with 20 different marks, that's great. But if we can represent them as a single number, such as the average, or we also call that the mean sometimes, that's a little bit easier to work with. Oh, okay, the class average is 75%. That gives me a quick snapshot of what's going on in the class without having to look at everyone's individual marks. So that is what we are planning to do in this lesson. First half, we're going to look at data collection and graphing though, and let's be a little bit more specific about our learning goals. By the end of this handout, by the end of this note, we would like to be able to collect data and represent it with a graph. And we would also like to be able to define and use terms related to data collection. So in order to learn about a topic, we need to know the correct vocabulary, the correct words to use to describe it. So let's dive right into some terms, and let's start with the term tally chart. And tally chart is also closely related to another term, that's the frequency distribution table. So I'll kind of talk about both at the same time here. Frequency distribution table. And that's also a term that we'll see when we talk about probability again. So our ideas, our topics of data collection and probability are closely connected together. And in fact, if you were to take grade 12 data, MDM4U, that course is all about probability and data collection and how do we interpret and analyze data. In general terms, a tally chart or a frequency distribution table is a table, a table used to record frequency. And you may have heard the term frequency before, either in relation to science or physics, or sometimes we talk about the frequency of light or the frequency of a radio station. But basically what we mean here when we say frequency is how often something occurs. How many times total did this event happen? And we represent that, or we organize that data using something like a tally chart or a frequency distribution table. And let's make a quick example and see what that looks like. In our example, we're going to look at the month in which students were born. We're going to have a column for tallies and a column frequency. And just for the sake of having enough room on this handout, I'm only going to take a look at the first few months. So let's assume that we're only going to look at January and February and March and April. January, February, March, April. All right, so we're in class. And I say, all right, everyone who's born in January, please raise your hand. One person raises their hand, and so we just make a quick tally mark. And how many people were born in February? Hands go up. 1, 2, 3. How many people were born in March? 1 hand. How many people were born in April? 5 hands. 1, 2, 3, 4, 5. Notice when I hit 5, I make the cross mark. And so basically I organize my numbers in groups of 5. And that enables me to quickly count them up later and get a feel for how many were actually there. And the advantage of using tally marks is that if I make a mistake or if somebody comes later, I can quickly change things. So let's say I just wrote down the number, the frequency, there's 3 people. And then someone comes back from the bathroom and says, oh, I was also born in February. Well, I can quickly make a tally mark, whereas I would have to scratch this out and write a new number. And then someone comes back from guidance and they say, oh, I was also born in February. Well, I gotta cross it out again. If I just have the tally marks, I can easily update them, and it keeps things nice and tidy. I just keep adding as needed. And also, what if we had to write them quickly? So let's say you're like in a factory, you're counting things as they go past on a conveyor belt. You can quickly make the tally marks in the moment and then go back and count them later for the frequency column. Our frequency column is where I actually add things up. I actually write down the numbers. So I'm done making my tally marks. I have finished counting all my birth dates in the class, or I'm done counting the things on the conveyor belt, or whatever it is that I'm doing. And so let's write down our number. So if we had one tally mark in our frequency portion, we're going to write down a 1. And 3 people were born in February, and 1 in March, and 5 in April. So remember, frequency is how often something happens. And so we're just writing how often did each outcome occur? How many items did we have in each category, so to speak? All right, our next term is population. And population is all the individuals or items under consideration. So if I want to know something about everyone at Lucas, the population would be the entire AB Lucas student body. But generally, it's not possible to talk to an entire population of people. It takes too long. It's too difficult or time consuming. And so instead, we often look at a sample instead. And a sample is a small group selected from a population. So maybe we just look at just the grade 9s, or maybe we randomly choose 20 people from grade 9 and from grade 10 and 11 and grade 12, something like that. So sample is the smaller group. As another example, we talked about, we looked at the election this morning. So population would be all the people who are eligible to vote, all the voters in America, whereas a sample would be a small group of people we look at for a poll. Maybe you randomly call 1,000 people across the states just to get a feel for the whole. But we're not talking to everyone, so that's just a sample. Or, final example, maybe we have like a factory where we make M&Ms. The population would be all the M&Ms produced that day. It's not practical or possible to stop the line and examine every single piece of candy that goes through. But maybe every hour or every batch, they take a big scoop out, they weigh them, they measure them, they check the color and the taste, and they say, yep, these are good to go. So sample is when we take a look at a small group or a small selection of items in order to more quickly or more easily get a view of the whole population. Next up, we have primary source. And here we're talking about where do I actually get my information from. And when we talk about a primary source, we're talking about a source that provides direct or first-hand evidence. So in this case, the reporter actually went and talked to the person themselves, or you went to the mall and you talked to people and you collected data about their shopping preferences or whatever. So first-hand means like it's only been in one hand. It's been picked directly by you. You've gone to the field and you've picked those strawberries yourself, or you've gone out and you've asked the public these questions yourself, or you've made these scientific measurements yourself. Secondary source, normally we think that it's not as good. It's not bad, it's just different. So when we talk about a secondary source, what's happening here is that they are describing, analyzing, interpreting, or evaluating primary sources or someone else's original work. So sometimes in science, a bunch of people will do original work, they'll collect data directly in the field, and then someone else will do a study where they look at all these different studies that were done over the past 50 years and then draw conclusions from those. So they didn't actually go make their own measurements, but they used other people's data and they made some broad generalizations or made some discoveries and trends and stuff. So there's nothing wrong with that. It's not less than primary source, but it is something to consider. And same with when we look at the news, you want to think, okay, did this place collect this information directly, or are they just summarizing a news article from somewhere else? And if they did they interpret it correctly? Did they actually quote the source of the information? Did they understand how the information was collected and presented in the first case? So that is something to watch out for, but let's write down our definition. A secondary source is one that describes, analyzes, interprets, or evaluates primary sources, or in other words, someone else's original work. And that's fine as long as they properly give their source of their work and they have a proper understanding of the original work. Sometimes they misinterpret and make mistakes, or intentionally misinterpret or make mistakes. So that is something to be aware of when we look at data collection, whether it's like statistics or probability or scientific data, or just generally in terms of things like the news. So we have some of the terms, we have some of the basic foundational pieces of information we need to talk about collecting data and working with it. Let's move on and let's talk briefly about graphs. We're not going to get too much into it here. We'll save that more for a future lesson, but just a quick overview of a few different types of graphs and when we might use them. Graphs are used to display collected data. Different graphs display different types of data. In each of the following three cases, identify why the type of graph selected to display the data is most appropriate. In our first case, we're going to talk about a column graph or a bar graph, or we also call it a column graph. So we kind of use those two terms interchangeably. And in our example here, we're taking a look at favorite flavor of Lifesavers. And we can see there's our number of respondents on the side here, and along the bottom, we have the flavors. So what kind of graph do we have here? Well, what we have here is a graph that compares categories. So when am I going to use a bar or column graph? I'm going to use it when I am comparing categories. And in our example here, what categories am I comparing? Well, I'm comparing the different flavors of Lifesaver. And the advantage of this graph is that I can quickly see what is the most popular flavor. Well, I can see it's lemon. I just look for the biggest bar. My eyes are used to quickly noticing patterns and noticing the largest object, so that's cool. What is the least favorite flavor? Once again, I can quickly look at the graph and I can just see, oh, it's butterscotch. No problem. And this is the advantage of graphs, because if I had, some kind of frequency distribution chart or tally table, a tally chart or frequency distribution table, that'd be great, but, I'd have a whole bunch of numbers I had to look at. Or if I just had the raw data from the respondents where they each wrote their favorite flavor down, I could maybe get a feel by kind of skimming and thinking, oh, I see the word lemon a lot. Maybe lemon's the most popular. But actually putting it formally together in a graph makes our life a lot easier. Next up, and this handout calls it a broken line graph. I'm just going to call it a line graph. When would I use a line graph? So you've seen these in math class before. They're used to compare variables. So I'm looking at how does the number of houses sold depend on the month. So x-axis is my independent variable. Y-axis is my dependent variable. But overall, in terms of data collection, I'm not talking about equations or anything. I'm just comparing two different things. And generally, when we talk about data collection, we're using this to represent trends over time. And I will, because this is in our college math class, we do use this in different ways. We'll also say the relationship of one variable to another. So we're looking at the connection between number of houses and time. But generally speaking, just think that we use this as trends over time. So we can see starting in January, not very many houses are being sold. It's going to increase as time goes on, peaking around June and July, which makes sense. People, the kids aren't in school in January or in July, August, or June, July, August area. So that's the time to move. We don't want to interrupt the school year, or that's when people have a break from their school or their job maybe. So, and the weather's nice. You can actually move and carry your boxes outside without worrying about slipping on the ice and being covered in snow. And then as the weather cools down and people are busy with school and jobs, and then we're all busy at Christmas and we don't want to move and the weather's bad, so less people are buying houses in the winter. And our final type of graph that we're going to look at for today is the circle graph, or I usually don't call it that. I usually call it a pie chart or a pie graph. And these are used to represent parts of a whole. When we talk about budgeting later, we'll talk about this briefly as well. So that's basically what's happening here. Jessica's spending, this is like her budget. Out of all the money that she has, or all the money that she spends, how much is spent on each category? And so we can see here that each slice is proportional to the percentage it represents. So the most amount of money she spends is on clothes, 35%. And so this slice of this pie goes 35% of the way around the pie. And we can convert and find out how many degrees that is and stuff, but we'll talk about that later. 30% of her money is spent on entertainment. So we see this slice is a little bit smaller, but it's going from here to here. That's 30% of the way around the circle. And then lunches, 15%. Transportation, 10%. And other, 10%. And so the size of the slice is proportional to what percent of the money is being spent in those categories. So we have visually, we can look at the size of the slices, and often we also have labels that say what category is this? Well, it's the clothing category. And what is the actual percentage? Well, it's 35%. And then number 2, we're not going to worry about down here. If you want to try that on your own for a couple minutes, that's fine. But since we are not in class together, we're not going to be comparing and sharing those answers, so that is completely optional. Moving on though, I said there was 3 things we were going to talk about. So we've talked about data collection and some of the terms used to describe it, and how there's different ways of getting data, either from primary sources where you collect it yourself, or a secondary source where you're using data collected by someone else, which is fine as long as you're giving your source and interpreting it correctly. We've talked about representing our data. So instead of having a big list of numbers, sometimes we can use our frequency table or our tally chart. Or we can use our graph. We've talked about different types of graphs and what they're used for. And later we'll look at how do we create them quickly using Google Sheets. And the final topic I wanted to talk about right now is measures of central tendency. And as I mentioned earlier, the idea here is that, like, basically imagine we have like, what's a good way to describe this? Basically, we can have like a dartboard, and we have a whole bunch of darts. And I want to say, what was the average position of these darts? Or where were most of these darts located at? And you're like, I don't know, like, how do I describe like the location of like a whole bunch of different things? Well, what if I just drew a dot in the middle? And I said, all the darts were pretty close to that position. Or that location is a pretty good average of where they were. That's what we do when we find measures of central tendency. Similarly, as I believe I mentioned earlier, if we have like a class of students and you say, oh, the average is 75%. Like, okay, I get a pretty good feel for how people are doing in this class. Some people are probably in the 90s, but the average is 75. So some people are probably in the 50s too, and bringing that average down. And so we just get a quick snapshot. It's not complete, but it's a way to summarize and just represent the data in a useful way that I can discuss and work with without being like, oh, how's everyone in the class doing? Well, there's a 38% and a 48% and a 52 and a 53 and a 72 and an 85 and a 91. And you're like, whoa, that's like way too much information. So that's why we use measures of central tendency to summarize and make it easier to talk about and just approximate and get a feel for what we're talking about. So what is our learning goal here? What are we trying to accomplish in this part of the handout? By the end of class or by the end of this part of the lesson, I would like to be able to interpret data. And I say interpret, but we can also say summarize, or it's kind of like rounding. I'm giving a good enough answer. And I want to do that by finding the mean, the median, the mode, and the range of a given set of data. And of course, in order to use those, in order to find those things, we need to understand what they are. So we'll do some quick vocabulary work and talk about those terms. What do we actually mean when we say those things? We'll take a look at the formulas. How do we calculate them? And then we'll work through a couple examples on paper and then also using Google Sheets. So let's take a look at the note portion. Note, to interpret data, it is often useful to use the middle of the data as the representative value of the data. There are three measures of central tendency: mean, median, and mode. Define each of these measures below. So the first one, and probably the most common one that you've used, is the mean, and mean just means the average. So mean is, we can call it the typical value. Alternatively, we can say it is the average of the given numbers and how do I find that? I do sum over count. In other words, I add up all the numbers and I divide by the number of numbers. And we'll work through an example of that a little bit further down the handout. Next up, we have the median. The median is the middle value of a sorted list of numbers. So it's the middle value of a sorted list of numbers. And the key word here is sorted. So I need to take my numbers and put them in order from largest to smallest and then find the middle number. So if I give you a bunch of random numbers that are like scrambled, you need to put them in order first before you find the median. And so just as a really quick example, let's say I have the numbers 1, 3, and 5. My median would be 3. What happens if I had an even amount of numbers? What if there were 4 numbers? So the other way to find the median is if there is an even count, so an even number of numbers, then we find the mean or average of the two central numbers. So let's say I had 1, 3, 4, and 5. Well, there is no middle number. It would appear here. So I need to figure out what's halfway between 3 and 4. So take my two central numbers, 3 and 4, add them together, divide by 2. That means we're finding the average. So it's going to be 7 over 2 or 3.5. So my median in this case is going to be 3.5. Finally, the mode. Mode is the number which appears most often. The number which appears most often. And that's pretty self-explanatory. Well, we'll still do an example in a few moments. I will also add the range. The range is not a measure of central tendency, but it is related. It is something we often find when working with a set of numbers. And the range is the difference And remember, we've talked before, what does it mean when we see difference? That's a key word that tells us we're going to subtract. We're going to find how far apart two numbers are from each other. So the difference between the largest and smallest values. Let's take a look at a few examples. So we're going to do the first few without technology. And by without technology, I just mean like using a calculator. And then our second example we'll do with technology. And by technology, I mean using a spreadsheet like Google Sheets or Excel. So we will use Google Sheets for all our work just because we all have access to that for free on the internet. And we can use it on any device, a Chromebook, a phone, whatever. I will sometimes accidentally say Excel because that's what I'm used to using personally most of the time. But basically, pretty much every function is the same between Excel and Google Sheets. They just have slightly different presentations, slightly different buttons and stuff sometimes. But overall, they are the same. So let's take a look. Example 1, without technology. We are asked to first find the mean. So remember, mean, what did we say? I'm not going to scroll back up, but you can pause and look at your own handout if you want. Mean is the average, and mean is equal to the sum. So add up over the numbers, all the numbers, divided by the count, where we divide by the number of numbers. So to find our sum, let's go through and add all our numbers up. So all our numbers are here. We see that Jessica recorded the length of her drives at a 9-hole golf tournament. The lengths were all given here. So to calculate the mean or average, we're going to add up all those numbers and divide by the number of numbers. So I would encourage you to pause the video and try this on your own first. And then when you're ready, follow along with me and check your work. So we're going to have the sum. We're going to add all the numbers up. So 190 plus 180 plus 205 plus 210 plus 165 plus 195 plus 200 plus 165 plus 185. And then divided by the number of numbers. So how many numbers are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to divide by 9. I would strongly encourage you to at least practice putting this in your calculator to get a feel for it. And we're going to find out that our total here is 1695 divided by 9, which is going to equal approximately 188.3 meters. And this is a word problem, so we could write a concluding statement, but I'm not really going to worry about that right now. But we would say, therefore, the average length of Jessica's drive during the tournament was 188.3 meters. Next up, we are asked to find the median. Remember, median is our middle number of a sorted list. So we're going to sort the list, and then we're going to find the middle value. So I'm going to arrange these numbers from lowest to highest. And once again, I would encourage you to pause the video and try that on your own before continuing. I've already done this previously, so I'm going to dive into the answer, but hopefully you've already paused and tried this on your own. Putting these numbers in order from lowest to greatest, I'm going to have 165, 165, 180, 185, 190, 195, 200, 205, and 210. And then we're just going to count from each side to find the middle number. So 1, 2, 3, 4, 1, 2, 3, 4. They meet in the middle at 190. So therefore, our median is 190, or therefore the median drive was 190 meters. It's really important that you sort, though. If I didn't sort, so I have students do this, they just look at the numbers up here. They just go, okay, 1, 2, 3, 4. 1, 2, 3, 4. Okay, the answer is 165. No, do not do that. You have to put the numbers in order first, please. Please remember to do that. Let's also calculate the mode. So what is the number that appears most often? And it's actually kind of helpful if we've done the median already, because I can use this list of numbers right here where they're all organized. So are there any numbers that appear more than once? So let's describe off to the side here quickly. The mode was the value that appears most often. And by looking at that list in the previous question, I can pretty quickly see that most numbers are not repeated, except for here. 165 appears twice. It is the only number that appears twice. So it is the number that appears the most often. So we can say, therefore, the mode is 165. And that is because it appears twice, while all other values are unique or only appear once. And as a bonus, let's find the range. What is the range of her drives? Well, range is just largest value minus smallest value, or maximum minus minimum. So we can see once again our ordered list here from B is pretty useful. What was her maximum drive? It was 210 meters. What was her shortest or minimum drive or smallest value? It was 165. And if we subtract those, we get an answer of 45. So therefore, the range, the difference between her farthest drive and shortest drive, or largest value and smallest value, was 45 meters. All right, for our second example, we're going to work with technology. And I'm actually going to make this into its own separate video. So please click through to that next video in order to see the demonstration answering this using technology, specifically using Google Sheets.